Hi, welcome to the video solution for physics past paper. This is Edexcel IAL Physics Unit 1, June 2014. Question number 1. A rocket of mass m lift off with an acceleration a due to the engine providing a thrust t. Which row in the table correctly identifies the quantities m, p and a as a scalar or vector? So m is the mass, which is a scalar quantity. T is the thrust, that means a force acting on a rocket, that means it is a vector quantity. And acceleration is a vector. So scalar, vector, vector. So option is C. Question number 2. The table shows a velocity time and acceleration time graphs for an object in motion. Which row of the table contains a pair of graphs that could be consistent for the motion of the object? So this is your first set of graph. This is your second set, a third, and the fourth, A, B, C, and D. If you see all the given option, you just immediately ignore option A and option B. Why is that? Because of acceleration time graph. Remember, in your specification, I mean in AS level, we deal acceleration with a constant magnitude. That means it is a uniform. So we deal motion with the uniform acceleration. So no matter what, your acceleration time graph should be a horizontal line parallel to the time axis. If you have a positive acceleration, so above the time axis. If you have a zero acceleration, so on the time axis. If you have negative, so it must be below the time axis. So for all questions, you must have horizontal or a straight line parallel to the time axis. That's why you can immediately ignore A and C. If you see the B and D, both acceleration are given positive values, and it is both are valid for the motion. But option D, velocity time graph is also horizontal, meaning if velocity time graph is horizontal, that means acceleration for this type of graph should be 0, and your acceleration time graph should be something like this. That means your option is B. And clearly you can see that if you find the gradient of this line, and the gradient shows acceleration, which is a positive value, that's why you have a positive acceleration. So your option is B. 4 identical steel balls are dropped simultaneously into test tubes filled with different motor oils. The diagram shows the position of balls after a short time. So 4 different fluid with different viscosity. Question 3. Which test tube A, B, C or D contains the oil with lowest viscosity? So lowest viscosity means if viscosity is low, that means rate of flow is higher. So if something is moving in a low viscosity fluid, so it should be moving faster than the other. So in test tube B, the steel ball has a lowest height, or you can say that steel ball in B has traveled more than the rest of the 3. So B has the lowest viscosity. So your option is B. Okay, same test tubes. Question number 4. Test tube D is heated and the ball is dropped into it in the same way. Compared with the previous experiment, the position of the ball in the test tube D after the same short time is. In this case, you can immediately ignore A and B. Why is that? Because you are heating the test tube. So if temperature is increased, that means viscosity is decreased. So the rate of flow is also increased. So it's easy to move, it's easy to flow for that kind of liquid. So the position of steel ball cannot be higher up than the previous one. That's why option A and B is immediately gone. And in option C and D, both options have lower position, but in C they are saying lower position or lower down because the viscosity is greater. No, it cannot be the option because temperature increase, viscosity decrease. So this oil viscosity is not greater, viscosity is lower. So the position of ball in D would be lower down because of the less viscosity. So option is D. 5. Two spring X and Y are stretched by the same force F. The spring constant X is double the spring constant of Y. If the energy stored in Y is E, the energy stored in X is given by. So this is energy stored in Y, and we need to find energy stored in X. And the condition is giving that a spring constant, which is K of X, is double the spring constant of Y. Remember, we have a relation between a spring constant and extension. If a spring constant is increased or higher, then the extension would be lower, because higher spring constant means you are increasing stiffness. If stiffness is increased, that means for a given amount of force, it is difficult to extend or to create extension in that kind of a spring. And in this case, if a spring constant is double, if K is double 2 times, then extension should be half of the previous one. Now, energy stored in spring Y is E. So EY, which is E, and you can say that E is half of Fx. X is the extension in Y for some force F, half of Fx for spring Y, and Ex is half of F because they have the same force, but extension is not X, extension is X by 2. Now if you bring 1 upon 2 before F, so you can rearrange the equation half of Fx, and this half of Fx is E. So Ex is half of E. That means option is B. Six, the coefficient of restitution of a ball is the ratio of its speed after it bounces to the speed before it bounces. The kinetic energy of the ball before it bounces is 3.3 and the kinetic energy after it bounces is 0.9. The coefficient of restitution is calculated using any one of the options. Okay, so coefficient of restitution, I am giving a symbol CR. Remember, it's not a standard symbol, it's just for understanding. So CR, coefficient of restitution. As per definition, if I have some, let's say a ball moving with some initial velocity and it hit the wall and then bounced back. So when it hit the wall with the velocity Vi and it bounces back with the velocity Vf, then coefficient of restitution is Vf, final velocity, divided by initial velocity. This is the definition of coefficient of restitution. And they are saying that the initial kinetic energy EI is 3.3 and the final kinetic energy after bounce is 0.9, and we need to find the expression for the coefficient of restitution. Because we know that the Vf over Vi is Cr, that means if I do Ef divided by Ei, meaning half of m Vf square divided by half of m Vi square. So half m cancel. I have only Vf square divided by Vi square. And if you substitute the value of kinetic energy, so you say that Vf square divided by Vi square is equal to 0.9 divided by 3.3. And if you remove the square, or if you take the square root, so you can say that Vf over Vi, after removing the square, it is the square root of 0.9 divided by 3.3, and Vf over V square is a coefficient of restitution. So your option is C. Seven is an increasing force is applied of the spring. Extension is measured. Spring constant K of the spring is okay. The applied force per unit extension. Okay, the idea is we cannot choose D. The reason is they are saying area under extension against force graph. So area against extension and force. If you find the area, so this area gives you energy, not the spring constant K. What about C? Gradient of extension against force. If you find the gradient of this line, extension on the y-axis and force on the x-axis, I'm talking about C. Extension on the y-axis and force on the x-axis. If you find the gradient, then the gradient would be equal to x upon f, which is not k, it is 1 upon k. And they are asking you the definition of k. If you see a straightforward formula, f equal to kx, then k is f upon x, force per unit extension. It is not a length, this is extension. So we cannot have option B, so that's why I chose A. Use the following photograph to answer the question 8 and 9. The photograph shows a tennis ball being thrown vertically upward. Which row of the table shows the correct direction of velocity and acceleration of the tennis ball while it is moving vertically upward? It is moving vertically upward. Remember, this is the example of free fall motion. Free fall motion. Or you can say it is an example of a projectile. In fact, it is a vertical projectile. So no matter what you say, you can say it is a free fall or it is a vertical projectile. Remember, for free fall motion, acceleration of the motion always remains downward because of the negative direction of the motion. And the reason is when the object is moving up or maybe coming down, in both cases, acceleration always acts downward because of the weight. Acceleration is due to weight and weight is acting down. That's why acceleration always acts downward. So immediately you can ignore option B and option D because of positive direction of the acceleration. So you could have option A and option C. As they are saying it is moving vertically upward, so your velocity is positive, so velocity must have a positive direction. In A, velocity is giving downward, which is showing a negative direction. So not A, C. Positive velocity, negative acceleration, option is C. Same situation, the tennis ball reaches a maximum height of 2.8 meter. The initial velocity would be given by. The idea is you throw some object from the ground. That means you give some initial velocity or maybe a kinetic energy at the start, due to which object will start moving up. As the object keeps moving up, kinetic energy starts decreasing or velocity decreases. After reaching some height, all the kinetic energy converts into gravitational potential energy. So you can say that half mv square is equal to mgh, and cancel, and if you make v as a subject, v is the velocity given to the object at the ground. So v is 2gh square root. So if you substitute all the numbers here, so 2g and h, so your option is C. Question number 10. Two forces F1 and F2 act on an object as in the diagram below, F1 and F2. If F1 and F2 are drawn to scale, the resultant force can be found by measuring the length of the resultant FR. Which of the following diagrams shows the correct position of the line FR? FR is the resultant of the two vector F1 plus F2 or F2 plus F1. So you must have the same result because it's a vector addition. So you can think in a way that you are joining either tail of the F2 with the head of the F1, like you see that if you drag F2 and you join tail of the F2 with the head, so you do that like something like this. So this is your F2, F1 plus F2, and this is your resultant. It should be your FR. So clearly, you cannot have A, B, and C. Your option is D. Sandstone is able to fault, meaning break, fold, meaning bend, and carry seismic earthquake waves. Fault can occur if the temperature of the sandstone is low enough for it to become brittle. This causes it to break under pressure. State and explain the properties of the sandstone that allow it to fold. So allow it to fold. So fold, if you see, folding means a bending, and you can bend a material if the material has a malleability property. That means it can be hammered into a sheet or show large plastic deformation under compressional force. Under compression force. So sandstone is a malleable, that's why it can be folded or bent. state and explain the properties of sandstone that allow it to carry seismic wave. Carrying a seismic wave means material or the medium has elastic property. Elastic property because sending waves is a behavior. Some particles takes energy and then go forward, transfer energy to the other particle and then go back to the original position to take more energy. So that's the mechanism of the, the flow of a wave. Go forward, take the energy, go forward, transfer energy and come back to the original position. That means if material has elastic property, it can carry a wave. So sandstone is elastic material or it has elastic property. That's it for this part. Thank you very much. Have a nice time.